Okay, let's take a second to talk about infinite sequences. An infinite sequence, and here my sequences are always infinite and real. I'm not generally going to say that they are infinite and real, but I will mean that they are. It's going to be implicit. I'll think of those as just a list of numbers in a specific order. So right here I have an example. It's this sequence that starts with 1/2 and then goes 1/4, 1/8, 1/16. That is just a sequence in which I divide each term by 2. So you can continue that if you want to. You can get 1/32, 1/64, 64, and so on. Another way to identify a sequence is to simply write a function that the sequence follows, or that the sequence obeys, a function of n. And here n is always going to be a natural number for you to be able to list your sequence as this guy being the first term, a1, this being the second term, a2, and so on. But sometimes it's kind of beneficial to start with a0, or maybe a-2, a-1, a0, a1, a2, a3, and so on. So you just always have to pay attention. Sometimes I'll indicate that this way as well by telling you which is the first term, the first n value that the sequence takes in as n. But either way, a1 is always going to be what I'll call the first term of the sequence. a2 is going to be the second term of the sequence. a3 is going to be the third term of the sequence. And an is going to be the nth term, or the general term of the sequence. So just got to be used to this wording here, and you will understand most things that we talk about when we talk about sequences. Very, very simply, if I'm given something like this for my an here being -1 to the power n times n plus 2 over 3 to the power n, and I want to find the fourth term of the sequence, all I'm being asked to do is to plug in n equal to 4. And then that will be a4 equals -1 to the power 4, 4 plus 2, 3 to the power 4. All I've done, very simple, is I've replaced every n that shows up with a 4. And then that's going to give me a positive, because -1 to that to an even power is going to be positive. 6 over 3 to the power 4. I can cancel one of the 3's like this to get a 2 over 27. And that will be the fourth term of my sequence. Okay. Another kind of problem that you are generally asked to do is finding the general term, finding an. So you're given the list, 3 over 5, comma, -4 over 25, comma, 5 over 125, -6 over 625, and so on. And then you're asked to find the formula for an. So you want to know what an is. So you have to sort of use this deductive thinking here. So let's think about this. Definitely, these terms are all fractions. And so, of course, I'm going to have a formula for an that goes like this. Some number in here, some number in here. Okay? I'm going to think about this piece by piece. Okay, one thing that I note for the top of this fraction, so maybe let me highlight that. It starts with 3 and then goes 4 and then 5, then 6, then 7. So it would be just n, right? It would be just n. When n equals 1, that'd be 1 though. So if I do n plus 2, when n equals 1, that's 3. When n equals 2, that's 4. When n equals 3, that's 5, and so on. So that seems to match, the n plus 2 seems to match the numerators of those fractions that I have in my list. So that's fine. I think this is the top of my fraction. Another thing that I haven't really pointed out yet, but you can kind of see, is that the terms of the sequence are alternating in sign, right? So there's one that's positive, and then one that's negative, one that's positive, one that's negative. So there's definitely a negative 1 to a certain power here up front to account for this change in sign. So there's positive, negative, and so on. So I will add this negative 1 to a certain power because that will be alternating. So usually, and you pay attention to this because this shows up all the time, usually either your power is going to be n or n plus something, because that's going to allow you to either start with the negative term or start with a positive term. So if I just leave it at this, when n equals 1, I'm going to get negative 1 to the power 1, and that's going to be negative 1. So that will make my first term negative, and that's not what I want. I want my first term to be positive. So what I do is I shift this, and I add an n plus 1. Because now, when n is 1, this will be negative 1 to the power 1 plus 1. So negative 1 squared, so positive 1, and the first term of the sequence will be positive. Okay, so right now we're doing a great job in finding those terms, those parts of the terms of the sequence. The only thing that we're still left to take care of are the denominators of those fractions. So if you pay close attention to this, you're going to see that each term here is multiplied by 5. So each denominator is the previous denominator multiplied by 5, or alternatively, these are the powers of 5, right? To have 5 and then 5 squared and then 5 cubed and then 5 to the power 4. So 125 times 5 should equal 625. And 625 times 5 should equal 3,125. And so I'm going to write 5 to the power n right here. And that should be the general term of my sequence. Okay? I'm going to write it again all in blue just to give you a little time if you want to copy down or just want to see it all in the same color. All right. You have to be careful sometimes with this idea of trying to guess the general term of the sequence, because there might be some weird rule that you may not be aware of for that particular sequence. So for example, if you have something like this sequence and I'm asked to find its 10th term, I could find a formula for its general term and then just plug n equal to 10 to that formula and figure it out. Or I can just extend the sequence that way. For example, I can do 4 and 3 and 2, 1, 0. And then naturally, the next term of the sequence would be negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, and so on, right? Decreasing by 1 every time. And then I can just count. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I could say that 8, 10 is negative 5. But no, this is not the only possible answer. A very, very common different way to interpret this question would be to think about something simple like an equals the absolute value, say, of 5 minus n. And when I think about it that way, you can see by calculating with this formula, a1 is absolute value 5 minus 1, which is absolute value 4, which is 4. A2 is absolute value 5 minus 2, which is absolute value 3, which is 3. So we're matching the sequence. And if you plug in A3, this is going to be 2, A4 is going to be 1, A5 is going to be 0. Everything is going to match with this new interpretation as well. However, if you do plug in, continue this way, and then you plug in A10, you're going to get the absolute value of 5 minus 10, which will be the absolute value of negative 5, which will be positive 5 and not negative 5. Okay? So you're found lost here. There's no correct choice. The general idea we're going to try and follow is this idea. It's a philosophical idea. It's not really something that mathematicians talk about all the time. That's Occam's razor. If you've ever heard of it, you know what it is. If you don't, Occam's razor is the idea that the the hypothesis with the fewest number of assumptions, basically the simplest answer, is the correct answer the majority of the time. So if you don't know anything else, if I didn't tell you, oh, use absolute values, or oh, don't use absolute values, you don't know what to choose, just choose the answer that has the fewest assumptions, basically the simplest of all answers. There's a way to formalize this mathematically speaking, using this idea of a Kolmogorov complexity of a function. But generally speaking, assume the simplest of all answers. I remember some time ago there was a meme going on with a sequence such as, like, sometimes it's an IQ test meme or something where you're going to see something like, find the next term of the sequence. And they're going to give you something really obvious, such as 1, 2, 3, 4, and then maybe put a question mark here. And obviously the answer should be 5 if we apply Occam's razor. But somebody who's trying to be pedantic could be trying to say something like, okay, no, so it can't be 5 because my an is n plus something like this, n minus 1, n minus 2, n minus 3, n minus 4, right? You can see that when I plug in n equals 1, this whole thing is going to be equal to 0. And so only this is going to be left over. So for n equals 1, n equals 2, n equals 3, n equals 4, this blue sequence here coincides with these. But if I plug in n equals 5, then I get 5 plus 5 minus 1, 5 minus 2, 5 minus 3, 5 minus 4. So this is in fact 4 times 3 times 2 times 1, okay, which will be 6 times 4, 24, plus 5, 29. So the next term could be 29, right? So what's the correct answer? Is it 29 or is it 5? You don't know. The sequence could actually go either way. But in a problem, in a math problem in general, trying to apply Occam's razor. What is the simplest assumption here? Not this. It is the assumption that the next term is probably 5. So being able to decide between complicated choices is also a skill you need to develop when dealing with sequences.